example 1b, we are again going to compute the values of the 6 trigonometric functions given specific information. The information we have at our disposal this time is that the tangent of theta is equal to negative square root of 7 over 2, and the secant of theta is greater than 0. Okay? We know the value of the tangent of theta, it's given, and our goal is to compute the values of the 5 remaining trigonometric functions. Okay, I have blanks to fill in at the bottom. I'm going to go ahead and write in the fact that the tangent of theta is the square root of 7 divided by 2. We've got to get the other 5. Okay, I will work this problem both ways. I will start this one off by drawing a triangle. Okay, the key to drawing a triangle before you can draw it, because you have to put it in the coordinate plane, is you have to know what quadrant you're located in. Okay, when we did part A, the problem came out and gave you the specific quadrant. The problem said, hey, we're in quadrant 3. Okay, that's not the case here. You have to figure it out based on the given information. But if you look at this, you can see that the tangent is negative and the secant is positive. So what quadrant is that happening in? If you go back to our sign chart on page 2 that we made at the very bottom here, we need a negative tangent. Okay, so tangent is negative in 4 and 2. That's where the tangent is negative. Okay, and we also need a positive secant. Okay, so if you look in the secant column, secant is positive in quadrant 1 and it's positive in quadrant 4. We need both conditions to happen, so the overlap is occurring in quadrant 4. Okay, so this tells us that we are in quadrant 4. Okay, so let's go ahead and draw our x-axis, and then I'll put the y-axis in. So here we go, and I need to draw the angle theta in quadrant 4. Okay, so again, remember how this is going to work. You want the angle to be in standard position. The initial side will coincide with the positive x-axis. To make the angle, we don't know the exact measure of theta. We don't need it. If you do a counterclockwise rotation, you're dealing with a positive angle. If you rotate clockwise from the positive x-axis, you're going to be dealing with a negative angle. Okay, let's just assume that we have a positive angle, so we would rotate around to the 4th quadrant, and so our terminal side would look something like this. Okay, so I'm going to go ahead and erase the arrowhead. Okay, and we need to make a right triangle out of this. So remember, the way to do that is you're going to go back to your terminal point where you left off, and you're going to go straight back, draw straight back to the x-axis. Okay, so this is how you make the right triangle. The angle theta, okay, so the question becomes, is theta this angle or is it this angle? The angle theta has to be inside your triangle. It has to be inside the triangle, and it's the angle made with the x-axis. So it is this particular angle that I have labeled. Okay, it's not the other one. Okay, so this is your theta value. Okay, we can go ahead and label the sides here if you want. If you draw straight across from theta, this is going to be the opposite side. The side directly across from the right angle is the hypotenuse. The remaining side is the adjacent side here. Okay, we are going to go ahead and use the given information, what we know about the tangent, to label the side with actual numbers. Okay. All right, so here we go. We are told that the tangent of theta is equal to negative square root of 7 divided by 2. Remember that tangent is the opposite over the adjacent. Okay, so now we kind of have to equate the fraction, the numerator with the opposite side and the denominator with the adjacent side, but we do have to be concerned about that negative sign. It can't be in both places, because if you had a negative divided by negative, that would be a positive tangent, and that's not what you have. We have to figure out where it goes. Okay, is the negative associated with the opposite side or with the adjacent side? Okay, well, in the 4th quadrant, you have positive x values and you have negative y values. So the adjacent side is along the positive x-axis, so the adjacent side needs to be positive. Okay, so the 2 needs to be positive, and then the opposite side, it is coinciding with it. The opposite side is below the x-axis, so you would think of like it's paralleling the negative y-axis. Okay, so you're going to have negative y values here. That opposite side needs to be negative. Okay, so when you look at this, the opposite side, we're going to label it with negative square root of 7. The adjacent side, we are going to label it with positive 2. And so it's going to look like this. I need to label the opposite side with a length of negative square root of 7. Okay, again, it's not the length that's negative, it's more because we're in the plane and we're in the 4th quadrant. Okay, so your y values are negative here. The adjacent side, I need to label that with positive 2. Okay, all right, we are missing the length of the hypotenuse. We need to get that. In order to get that, we have to apply the Pythagorean theorem. C squared, remember C represents the hypotenuse. That is going to be a squared plus b squared. Okay, we are solving for c squared because we need the hypotenuse. So I'm going to go ahead and plug in a squared. So I just typically use a for adjacent. So this is going to be 2 squared plus the b value, the opposite side, squared. This is going to be negative square root of 7 squared. So c squared is going to be 4 plus negative gets squared, so negative times negative is positive. Square root of 7 times itself is positive 7. Okay, so this is going to be 11. C squared is 11. So if you take the square root of both sides, okay, let me do it in a different color here. If you take this square root of both sides, take the square root of the left side, and then on the right side, make sure you put the plus or minus out front. Okay, so on the left, the square and the square root cancel, leaving you with c. We're going to get c. The possible values of the hypotenuse are plus or minus the square root of 11. But remember, the hypotenuse is always positive, so the c value has to be the positive square root of 11. Okay, and we can go ahead and label that in the triangle. Okay, now that we have our triangle fully drawn and fully labeled, we can use it to get our remaining 5 trigonometric values. Okay, so let's get started. I will start with the first blank, which is a sine value. Okay, so the sine of theta is equal to the opposite over the hypotenuse. So just read this off the triangle. The opposite side is the negative square root of 7. Put that in the numerator. The hypotenuse is the square root of 11. Okay, so there you go. We do need to rationalize the denominator here. So I'm going to multiply the top and bottom by the square root of 11. And now we're going to multiply across the top and multiply across the bottom. This is going to be negative square root of 7 times the square root of 11. The bottom, square root of 11 times square root of 11 will just be 11. And if you remember properties of square roots, if you have a square root times another square root, you can just multiply what's inside. Okay, so you can combine these into one. The top is going to be the square root of negative 77 over 11. Okay, that is the sine value. So I'm going to go ahead and write it in. Leave it as an exact answer. Do not give me a decimal. Okay, all right, moving on. I will now, since I just did sine is related to cosecant, so I'm going to do the cosecant now. Okay, so to form the cosecant of theta, okay, that is going to basically be the flip of the sine, so it's going to be the hypotenuse over the opposite side. Read it off your triangle. The hypotenuse is the square root of 11. The opposite side is the negative square root of 7. Okay, so now we just need to rationalize this. Okay, so I'm going to multiply the top and the bottom by the square root of 7. Okay, and now I'm going to multiply across the top and across the bottom. Okay, so if we multiply across the top, we can just go ahead and combine these into one radical. This is going to be the square root of 77 over and remember this is going to be a negative value, the square root of 7 times the square root of 7 is just 7. Okay, so my cosecant value is negative square root of 77 over 7. Okay. All right, moving on. I am going to get the cosine value. So I will go ahead and put that right here. Okay, so for this next one, the third function here, we'll do cosine of theta. Okay, cosine is the adjacent over the hypotenuse. Okay, just read it off the triangle. The adjacent side is 2. So this is going to be 2 over the hypotenuse is the square root of 11. Rationalize the denominator, so I'm going to multiply top and bottom by the square root of 11. Multiply across the top and across the bottom. Okay, we're going to get 2 square root of 11 over 11. Okay, so that is the value of the cosine. So let me fill that in. All right, I'm going to move to the next page and I'm going to start working on the secant. Okay, so the secant of theta, that is going to be basically the flip of the cosine. This is going to be the hypotenuse over the adjacent side. Okay, so if I go back to my triangle and read that off, the hypotenuse is the square root of 11. So that goes in the numerator. The denominator is the adjacent side. The adjacent side is 2. Okay, so that's it. I don't have anything to simplify, so I'll go back and fill this in. The secant is going to be the square root of 11 over 2. Okay, and then all I need now is the cotangent of theta. So the cotangent of theta, that is just basically the flip of the tangent. Tangent is opposite over adjacent, so cotangent is going to be adjacent over opposite. Okay, we know the adjacent side is 2. The opposite side is negative square root of 7. Okay, so that's how we put it together. Now we just need to rationalize, multiply the top and the bottom by the square root of 7. Okay, this is going to be 2 square root of 7 over negative 7. Okay, so there's your answer for the cotangent. It is negative 2 square root of 7 over 7. Okay, we are done. We have all 6 trigonometric functions. Okay, they are all exact values. And remember, I'm in quadrant 4. So the only positive trig functions I should have are cosine and secant. Everything else should be negative. Okay, I will rework this problem in the next video using the fundamental identities only and not drawing a triangle.